If you want to learn what a diesel hammer is, what it is used for, how it works, and the secrets of its operation, then this video will be very interesting for you. We will talk about a pile-driving tubular diesel hammer. Using 3D graphics, we will show you the details and secrets of pile driving step by step. Diesel pile drivers are designed for driving reinforced concrete and metal piles and sheet piles into the ground when constructing foundations in both civil and industrial construction. Let's look at a pile driver based on a crane or cable excavator. A diesel hammer with a head attached to it can move along a guide mast. The pile driver pulls the pile up and sets it in the design position. The driving cap of the pile hammer is placed on the head of the pile. A shock-absorbing gasket made of rubber, wood, or other elastic materials is installed between the pile and the head. The striking part, hammer, is lifted by a winch and dropped from a height. When the striking part falls, diesel fuel is injected. Detonation occurs. The impact energy drives the pile in, and the energy of the explosion throws the striker upward for the next cycle. If the pile is deeply embedded at the beginning of driving, the hammer may not start even after several attempts. And when the pile is difficult to drive, the hammer may start. The working hammer is stopped by the tension of the rope attached to the fuel pump plunger lever. Let's take a closer look at this process and the design of the diesel hammer. This is a driving cap. It is attached to the diesel hammer with slings. There is a shock-absorbing gasket inside the driving cap. The gasket is needed to prevent the pile from breaking. This is a cushioning gasket between the hammer and the driving cap. This is the guide cylinder. The guide cylinder is a thick-walled pipe. There is a longitudinal slot on its side surface into which the lifting lever fits. Two stops are attached to this cylinder. The stops are needed to switch the mechanism for gripping and releasing the striking part. This is the working cylinder. In the middle part of the cylinder, there are four exhaust pipes, which serve to suck air into the cylinder and remove exhaust gases from it. The working cylinder also has a slot for the fuel pump lever. The hammer is water-cooled. A ring-shaped water tank with fill and drain ports is installed in the lower part of the working cylinder. A ring-shaped fuel tank with a fill port is located in the upper part of the cylinder. This is a combined fuel pump. It is attached to the working cylinder. Plunger pump, low pressure, used to supply fuel to the combustion chamber and oil to lubricate the piston and anvil. This is the oil tank. These are the oil and fuel pipes. This is the striking part, a heavy metal cylinder. This cylinder, like the piston in an internal combustion engine, has compression rings. This is the anvil. The anvil is inserted into the lower part of the working cylinder and can move along it so that the piston's blows on the sabot do not affect the cylinder. The movement of the anvil is limited by guide bearings. Upper bearing, lower bearing. When moving down, the impact part drives the fuel pump lever. The lever presses on the fuel and oil pump plunger. When lowered, the plunger creates pressure in the pump cavity. Fuel is injected into the combustion chamber. Detonation occurs. The impact energy drives the pile, and the explosion energy throws the impact part up for the next cycle. The oil plunger displaces oil through two fittings to lubricate the piston and the anvil. Lifting and release mechanism of the hammer. It is a lever mechanism designed for automatic gripping, lifting to the upper position, and automatic release of the piston when the hammer is started. It is also used to lift the entire hammer up the derrick mast. It consists of a body and a lever mechanism. The lever mechanism is incredibly simple but amazing. It can occupy two positions, working and idle. In the idle position, the end of the lever is lowered and does not engage with the ring notch of the piston. In the working position, the lifting lever is raised and engages with the ring notch of the piston. In the working position, the lever mechanism securely holds the striking mechanism. The shaft fixed in the housing prevents the lever from turning upward. A spring clip prevents the lever from turning downward. To engage the piston, the lifting and release mechanism is lowered. The lever, pushing against the stop, rotates and brings the lifting and release mechanism into the working position. When lifted, the protruding end of the lever lifts the piston upward until the lever passes the release stop. When the lifting and release mechanism passes the release stop, the switch lever switches the mechanism to the idle position. The piston falls freely downward. The principle of operation of a diesel hammer is quite simple. The cylinder rises to the stop and then descends with force. The air is compressed during the descent, which increases the temperature, and after a portion of fuel is supplied, ignition occurs, causing the cylinder to rise sharply. After reaching the top point, the air in the cylinder is compressed again.